Time travel. We've all thought about it, right? It's fueled our imaginations for centuries. But what if I told you that beneath all that science fiction, there's a bedrock of real, actual physics? Well, in this explainer, that's exactly what we're going to do. We're peeling back the layers of fantasy to get to the fascinating truth.
So, the big question, is it all just a dream? Something we cook up for books and movies? The answer from the world of physics is way more complex and, frankly, a whole lot more exciting than you probably think.
I mean, for as long as we've been telling stories, we've been completely obsessed with conquering time. It's the ultimate power, isn't it? The chance to see the past with your own eyes, or to just leap into the future. That dream it's baked into our culture. You've got H.G. Wells imagining his time machine way back in the 19th century, and then you fast forward to Albert Einstein, who completely flipped our understanding of time on its head. It's thinkers like them who helped turn this idea from just pure fantasy into a question that, believe it or not, physicists take very, very seriously.
And this is where we take our first huge leap from fiction right into fact. Because I'm about to tell you something that sounds like it's straight out of a Hollywood blockbuster, but it is 100% scientifically proven.
Yeah, you heard that right. Traveling into the future is physically possible. This isn't just some wild idea. It's a fundamental consequence of how our universe actually works, all laid out in Einstein's theory of relativity.
And the secret sauce behind it all is this beautifully strange concept called time dilation. See, what it tells us is that time isn't absolute. It doesn't tick away at the same rate for everybody. No, it's relative. And it can be stretched or compressed by two huge forces in our universe, speed and gravity.
So you basically have two recipes for a trip to the future. Einstein's special relativity tells us that the faster you zoom through space, the slower you move through time. If you could get close to the speed of light, time for you would slow to a crawl compared to someone back on Earth. And then, general relativity gives us another way, gravity. The stronger the gravitational pull, say near a black hole, the more it warps space-time itself, and the slower time passes.
And hey, this isn't just theory. We see proof of this every single day. In particle accelerators, these tiny particles called muons survive way longer than they should because they're traveling at almost the speed of light. We've even measured this with super precise atomic clocks on airplanes. But the most incredible example? The GPS in your phone. Seriously. Those satellites are orbiting so fast and are in a weaker gravitational field that their clocks actually tick at a different rate than ours. If we didn't constantly correct for time dilation, your GPS would be off by miles every single day.
Okay, so traveling to the future? It's on the table. But what about going the other way? Leaping into the past? Well, this is where physics goes from weird to just mind-bendingly strange.
Look, if forward travel is like a nicely paved highway, then backward travel is like trying to navigate a dense theoretical jungle with no map. We're leaving the world of things we've actually proven and entering the realm of mathematical possibilities. These are ideas that work on paper, but they come with some truly enormous cosmic asterisks.
So, here are the main contenders. You've got wormholes, right? These theoretical tunnels through the fabric of spacetime. The catch? You'd need something called exotic matter with negative mass to prop it open. And, well, we've never found anything like it. Then there's the Tipler cylinder, which is a massive, infinitely long spinning cylinder that could literally twist spacetime into loops. The problem there, of course, is the whole infinitely long part. All of these are what physicists call closed, time-like curves, paths that could, in theory, lead you right back to where and when you started.
But let's just say we could overcome these completely impossible engineering challenges. We'd still run headfirst into a much bigger problem. And this one isn't a problem of physics, but of pure, simple logic. This is really the heart of the matter. The second you can go backward in time, you can potentially mess with the chain of cause and effect that led to you even being there. And this brings us to probably the most famous thought experiment in all of time travel.
All right, let's walk through this together. It's so simple, but so profound. You go back. You stop your grandparents from meeting. That means your parent is never born, which means you are never born. So, if you were never born, who went back in time to stop them in the first place? Boom! The whole thing just collapses on itself.
It's a perfect contradiction, a causal loop that just breaks itself. And for a long time, this really seemed like a deal breaker, like a clear sign from the universe saying, sorry, the past is off limits. But then some physicists came up with a really clever, if a little strange, potential way around it.
It's called the Novikov self-consistency principle, and it's this incredibly elegant idea that basically says the universe has its own built-in paradox protection system.
So, what this means is that the universe simply will not allow a contradiction to happen. Sure, you could travel to the past, but you'd find yourself physically unable to change it. Your gun would jam, you'd slip on a banana peel, or in a wild twist of fate, maybe your attempt to stop your grandparents from meeting is the very thing that causes them to meet. In this model, you're not an editor of history, you're just another part of it.
So, after digging through all the science, the crazy theories, and the paradoxes, where do we land? What's the final verdict on time travel?
Let's just break it down nice and simple. Traveling to the future? That's a scientific fact. We've proven it. The only thing stopping us is an engineering problem. Okay, a massive one, but still. Now, travel to the past? That's a totally different story. It's like a mathematical ghost. It's possible on paper in these very specific extreme scenarios, but it's haunted by paradoxes and requires technology that might just be fundamentally impossible.
And that's pretty much where we stand. We can't go back and undo the past. But think about this. For any future astronauts on a long journey to another star, time dilation means their return home would be a profound shock. They might age only a few years, but back on Earth, centuries, maybe even millennia could have passed. Their journey through space would literally be a one-way ticket to the future.
Which brings us to one last thought. Just imagine we could overcome every single hurdle. We solve the paradoxes. We build the machine. We have the ultimate power in our hands. The question then isn't can we, but should we? Something to think about.